Hello everyone, here we are in the IIT-JAM chemistry tutorial number 4 and in the third lecture of basic mathematical concept. Here we are going to discuss vectors, matrices, determinants, elementary statistics and probability. First of all, we shall start from the elementary statistics and probability theory. Okay, firstly, mathematical probability, and it's defined as if an event can happen in p ways and fails to happen in q ways, and if each of these ways are equally likely, then the mathematical probability m has the expression for happening is p over p plus q and for not happening is q over p plus q. Now the examples here in the left hand side, the events, and here in the right hand side the mathematical probability m, and tossing a single coin, so either head or tail, so the probability is 50%. That means mathematical probability for happening is half and for not happening is half also. Throwing a single die, so any side will be shown, suppose 6 or 1, it will be 1 by 6, and for not happening it is 5 by 6. Throwing double dice, okay, so two sides simultaneously, suppose 2 1 or 1 and 2 or 6 and 5, so this way you can combine 36 numbers of combinations, and this way each pair of two faces would be probably happen by 1 by 36 ways. Okay, so mathematical probability of happening of two faces to be shown in a single time is 1 by 36, and for not happening is 35 by 36. Okay, and if you throw two coins together, suppose a 1 rupee coin and a 2 rupee coin, so the head of 1 rupee coin, head of 2 rupee coin, head of 1 rupee coin, tail of 2 rupee coin, then tail of 1 rupee coin, head of 2 rupee coin, then tail of 1 rupee coin and tail of 2 rupee coin. So there are 4 probabilities. So each pair of two faces has the probability of happening 1 by 4 and for not happening 3 by 4. Here are 3 Cartesian coordinates which are orthogonal, that means they are perpendicular to each other, the x-axis, y-axis and the z-axis, and here is the bold colored red line representing a vector which has a magnitude and a direction too. Now on the projection on the each axis, suppose this is the projection, here this is actually ax, this is ay, projection on the y-axis, and here in the projection in the z-axis it is az. Now the unit vectors along x-axis is I, the unit vector along y-axis is j, and along z-axis is k. So the magnitude should be, actually the vector should be represented as a equals to iax, jay, and kaz. So vector A can be analyzed into 3 component vectors or unit vectors I, j and k. If ax, ay and az are their absolute values respectively, then it can be represented as iax plus jay plus kaz. So simply this vector A, it is represented by means of its 3 unit vectors I, j and k, and the I, j and k are multiplied with the absolute values along x-axis, y-axis and z-axis respectively. So this is the representation. Okay, so what is the absolute value? That means the magnitude. The magnitude, that means the length from here to here. Okay, this is not the direction. Direction is actually the direction cosine, cos theta value, that is different, but this is the magnitude. That means the length from the origin to this point is actually root over ax square plus ay square plus az square. Okay, conversely you can also in the reverse way can say that here are 3 vectors, okay, iax, jay and kaz, and the resultant vectors of these 3, that means summation of these 3 is a. Okay, this can also be said. So conversely, a is the resultant vector of the 3 orthogonally perpendicular vectors iax, jay, and kaz along x, y and z axis respectively. Now scalar product or dot product of 2 vectors. Okay, dot product of 2 vectors, suppose p, here is p is one vector and q is another vector, so the dot product of these 2 vectors p dot q is actually px qx plus py qy plus pz qz. Why? Because if you multiply these 2, then these terms would come I dot j, j dot k or k dot I, but these values, the scalar product of these 2 or any 2 orthogonal vectors is 0, because cos 90 is 0. Okay, so cos theta comes here, I, j cos theta, so since cos 90 is 0, so these values are 0, but cos 0 is 1, in that case II equal to I magnitude into cos theta, that means 1. Okay, since they are unit vectors, so the value is finally 1 into cos 0, that means 1. So I remains in this equation, but ij or jk or ki vanishes. So this is the final result. So for the example of scalar product of two vectors, suppose work is a vector which has two components, force and displacement. This is the force vector, this is the displacement vector. Okay, and you can undergo scalar product of these two, force into displacement equal to work. Okay, so you can undergo scalar product or dot product. Now the vector product or cross product, if these two are the vectors, then expression is sin theta. Instead of cos theta, it is sin theta. So here it is like a determinant. Determinants will also be discussed today, but look how the cross product A cross B, and here we must say, before saying A cross B, B cross A is different. Okay, actually A cross B equals to minus B cross A. So the cross product is a little bit difficult rather than scalar product, and here it can be represented, the resultant vector is not a resultant vector, that means the product vector. And one more thing, the product vector is orthogonal to these two vectors. These two vectors, you are just making a cross product, and the result is perpendicular to both these two vectors. That means if they are in the xy plane, then along the z axis you will get the product. Okay, A and B are in the xy plane. Maybe they are orthogonal or they are not orthogonal, but they are in the plane xy. So the result is what? Now from the origin along the y axis, it is the cross product, and in the minus y axis you will get the cross product, reverse cross product, that means B cross A. Okay, so it's a little bit different, and there is the sin theta value. So due to that, the result is I into AYBZ minus AZBY, that means determinant result. Okay, then J into AZBX minus AXBZ, and then K into AXBY minus AYBX. Okay. Actually the cross product is nothing but the product of the two magnitudes and then sin theta. Theta is the angle between the two vectors. So in this context, I into I means what? I into I means 1 into 1 into sin 0 degree. Similarly, J into J cross J means J 1 into 1 into sin 0 degree. So these are all 0. On the other hand, I into J is nothing but K, or J into I is minus K. That means minus J into I is also equals to K. Similarly, J cross K equals to minus K cross J equals to I, and K cross I equals to minus I cross K equals to J. So that is why this type of product has been obtained. Okay, and the best example is position vector cross momentum vector is nothing but angular momentum. Okay, so if position vector and momentum vector are in one plane, then angular momentum is in the orthogonal axis. Okay, if they are in the xy plane, then it is in the along the z axis from the origin to plus z axis. Okay, and if you cross product undergo the cross product of momentum and position, it will be in along the minus z axis. So this is about the cross product. Now question number 1. Okay, this question came in the IIT-JAM admission test in 2006. So for a particle with position r vector equals to twice I minus 3j plus k, and momentum p vector equals to I plus twice j minus twice k in kilogram per meter in m, that means meter. This one is in the meter unit, and in kilogram meter per second, that means that is momentum, that means mass into velocity. Okay, mass into velocity means what? Momentum. So kg meter per second. Okay, so this one has the unit meter and this one has the unit kg meter per second respectively. So calculate the magnitude of the angular momentum. So angular momentum is L, and this is the actually cross product R and P. Okay, cross product of R and P. So the position vectors we are given these two, this one, and the momentum vector this one. Okay, so the angular momentum vector is what? It is L, and this is the cross product of R and P. So R cross P. Here the result is I into AXBY minus B AXBY minus AYBZ minus BYAZ. then j into az bx minus ax bz plus k into ax by minus ay bx. So here these values, minus 3 into minus 2 minus, then here it is 1 and here it is 2. Okay, so this way you get the cross product. So the vector is actually 4i plus 5j plus 7k, and the magnitude is root over ax square, actually this one square plus this one square into this one square plus this one square. Okay, and the result should be what? Now meter into kg meter per second, that means kg meter square per second, and it is 9.5 kg meter square per second. So this way you can calculate the angular momentum. Okay, now the next question. Here is the question number 2. A vector A equals to I plus xj plus 3k is rotated through an angle and is doubled in magnitude, resulting in another vector B, 4i plus 4x minus 2 into j plus twice k. So the acceptable value of x is what? So actually here the angle of rotation is not required because the magnitude is just doubled. So just find out the magnitude of this one, then multiply this with 2 and equate the magnitude with b. Okay, so this way the magnitude of A is just here 1, here x, and here 3, isn't it? So you have to square them, 1 square plus x square plus 3 square, and then add them and then take the root over. So the value is root over 10 plus x square, and the magnitude of B, what? It is actually the double of this one, twice A. Okay, so the magnitude of B is square of 4, square of this one, and square of 2. Their addition, their summation, and then it's root over. Oh, so it's finally root over 20 plus 4x minus 2 whole square, and this is actually nothing but equals to 2. Okay, that means just multiply root over 10 plus x square with 2 and equate this with this one. So this way is 2 into root over 10 plus x square equals to root over 20 plus 4x minus 2 whole square, and then after having solved this one we get two values, x equals to 2 and minus 2.3, and here in the options 1, 2, 3 and 4 by 3. So minus 2 by 3 isn't here, so another acceptable value of x2 is here, so the correct option is B. Okay, this is question number 2. Now move on to question number 3. For 3 non-coplanar vectors A, B and C, okay, the expression of A dot B cross C can be written as what? Okay, so here are 4 options. These are all non-coplanar, that means they are not at all in the same plane. In that case we see that A dot B cross C, okay, this is actually B cross C dot A because they are commutative, and this here you can also write B dot C cross A into C cross A into B. On the other hand, C dot A cross B into C. So here the correct option should be this one, isn't it? Because it comes here A cross B dot C, here A cross B dot C, and it was here A dot B cross C, it is here. Okay, so these are all acceptable values. So any one of them out of this which is being shown here in these 4 options, this one is coming. So this one is the option A, this one is the correct option. Okay, now move on to another topic which is matrix, and its plural is matrices. Okay, so we have the following set of linear equations representing A, B and C as, these are the linear equations: A equals to A1x plus A2y plus A3z, B equals to B1x plus B2y plus B3z, and finally C equals to C1x plus C2y plus C3z. Okay, so A, B and C transformed coordinates obtained from x, y and z is, okay, the A, B and C transformed coordinates obtained from x, y and z is what? This is this one. Okay, so you can represent this, all these 3 linear equations this way. So if this matrix relationships is given to you, then you can easily prepare the linear relations like this one. Okay, from here to here, or from here, or vice versa, from here to here. Okay, so the coordinate values x, y and z, this one in the right hand side, and the coefficients in the matrix. Matrix means column. Okay, so column of A1, B1 and C1. Look here, A2, B2 and C2, A2, B2 and C2, and here A3, B3 and C3, here A3, B3 and C3. And so this is transforming, X, Y and Z is transforming this value into A, B and C. So A, B and C are also in the matrix. So matrix are always enclosed by these brackets. Okay, sometimes first brackets, that means first bracket, yes, parenthesis is also used. Now transposition of a matrix. What is transposition of a matrix? If A is represented like this one, A1, B1, C1, A2, B2, C2 and A3, B3, C3 according to the column, then its transposition is just changing the columns into rows and rows into columns. That means A1, B1, C1, it was forming the column, now it will form the row A1, B1, C1 here. A2, B2, C2 is forming the second column, so it will form the second row now, A2, B2, C2. Similarly, A3, B3, C3 will form the third row instead of third column. So it is sometimes written as A prime or here A to the power T. Okay, this is transposition of a matrix. Now conformability, product and transformation of a matrix. Suppose you have two matrices A and B, and they would be said to be conformable. Okay, for the product, that means you can undergo their multiplication. So the product is A and B, but you cannot do this product until it is conformable. So what is conformability? Conformability is actually the number of rows should be equal to the number of column. Okay, look here, if A be an M into N matrix, that means M into N ordered matrix, and B and N into P ordered matrix, then their product AB is defined to be the M into P matrix. Okay, that means N should be common here, N into P here, and here M into N. Okay, so N is the number of column here, and here N is the number of row here. So these two are equal, and finally you will get a new matrix which will consist of M number of rows and P number of columns. Okay, so this is an M into P ordered matrix, and it will have the I into jth element, I which is obtained by multiplying the elements of the ith row of A into the corresponding elements of jth column of B and summing the products so obtained. How? Look. And another thing, the sum is called inner product of the ith row of A and the jth column of B. So how it comes? Look here. Suppose this is a 3 into 2 matrix A, and this is a 2 into 3 matrix. So what should be the final product? It should be 3 into 3 product, isn't it? Because its number of row is 2 here, number of column is 2, and here number of row is 2. Okay, so what should be the value of AB? Look, this one into this one, okay, plus this one into this one. It will form the first element. Clear? So the rows of the first matrix into the column of the second matrix and their addition forming the first element. Then the second element means this one, this is the second element. Again these two, but now instead of these two we have to multiply these two. So A11 with B22 plus A12 plus B22. So this way you will get all the 9 elements of the AB product. Okay, so have a look. Finally here in the last one, A31, that means this one into what? AB13 plus A32 into B23. So this one, okay, this is the last element. This way you will get all the 9 elements. Here the ijth element of the product AB is the inner product of the ith row of A and jth column of B. In the product AB, A is called the prefactor and B is called the postfactor. Moreover, B is pre-multiplied by A or A is post-multiplied by B if it is AB, okay, and vice versa. Now commutative law of matrices. Look, if A and B are two matrices of 3 to 3 order such that this is the A matrix, this is the B matrix, okay, then their multiplication AB should be what? So you know the rule. You will get a 3 into 3 vector, a 3 into 3 matrix. The first column, this 3 into this 3, their addition, the first element. The second element, this 3 into this 3, their addition. Okay, this is the second element. This way, finally last element, this 3 into this 3. Okay, this is the last element. A31, B31. Okay, then A32, B32, and finally A33, B33. Is it clear? And this is AB, and if AB equals to BA, then they are commutative. And if AB not equal to BA, then they are not commutative. So if you get the values of corresponding A1, B1, A2, B2, etc., then you can verify that whether they are commutative or not. Now, square, diagonal, identity, and scalar matrix. We shall start from identity matrix. Okay, the last one. Identity matrix is a scalar matrix having one only on the main diagonal and zeros everywhere else. Okay, this is an identity matrix and it is denoted as I suffix small letter I. Okay, so we have a term here, scalar matrix. Before going to scalar matrix, let's explain the identity matrix with example. This is a 1 into 1 identity matrix, only one. This is the element, but diagonally 1 and 1 if it is a 2 into 2 matrix, and diagonally here 1, 1, 1. This is a 3 into 3 matrix. This is not only a scalar matrix, this is a diagonal matrix also, and this is a square matrix also. So let's know the terms. What about scalar matrix? Scalar matrix is a diagonal matrix, okay, which have equal diagonal elements. That is called a square matrix. That means here, suppose this is an identity, instead of 1, 1, 1, you just put 2, 2, 2, or 3, 3, 3, or 10, 10, 10, whatever be the value, all the three values are same. Then these types of matrices are known as scalar matrices. Now the terminology comes diagonal matrix. So what is the diagonal matrix? A square matrix having all elements zeros except the diagonal elements. This is called a diagonal matrix. So suppose this is an example of a diagonal matrix, definitely, and these values may not be equal or may be equal, whatever, but this is an example of a diagonal matrix. Now come to the point, square matrix. What is a square matrix? Now, a matrix with equal number of rows and columns is a square matrix. Here you find that it is a 3 into 3 matrix. So the number of rows is equal to number of columns. So this is the example of a square matrix. So all the identity matrices are scalar matrices, diagonal matrices, and square matrices. But the vice versa is not correct. All the scalar matrices are diagonal matrices and square matrices. But the reverse statement is not correct. All the diagonal matrices are square matrices, but all the square matrices are not diagonal matrices. Okay, so this way, square matrix to diagonal matrix to scalar matrix, and then scalar matrix to identity matrix. And you have some notations like diagonal matrix as small letter d suffix small I, scalar matrix only small letter d within the third bracket. Okay, and square matrix has no expression, no notation. Okay, now move on to question number 4. So with I, j, and k as the unit vectors along x, y, and z axis, express the vectors p1, p2 in the given figure. This figure. This is the p1 vector, this is the p2 vector, and this is p1, p2 vector. This is simply the vector subtraction, isn't it? This is not vector addition. This is vector subtraction, because vector addition would have given the resultant vector along this way, but this is p2 minus p1. Okay, so, and you have to deduce another question. The same year, IIT-JAM 2007, deduce whether the matrices A and B are commutative or not. Okay, answer number 4A. P1, P2 vector is therefore P2 minus P1. As I have said, this is the subtraction of two vectors. So P2 vector minus P1 vector. Okay, and the result is x2 minus x1 I, y2 minus y1 z, and z2 minus z1 k. Okay, and the dot products of I, j, and k. This is the result. Okay, and you are also asked about the dot products of each unit vectors. You know this because they are making a 0 degree angle and cos 0 is 1, so this is 1, isn't it? And if it is multiplied with different vectors, that means I with j and or j with k or I with j with k, then it is 0, because they are forming 90-degree angle. So cos 90 degree is 0. So if it would have been the dot product of I with I, then it would have been 1, j with j 1, k with k 1. But you are asked to find out the value I dot j dot k. So I dot j is definitely 0, and 0 into k is 0. Okay. And answer 4b. 4b is, you are given that these are the two matrices. A is 2 1 0 1 and B is 1 1 0 1. Then AB is what? AB is the product of these two. That means 2 into 1 plus 1 into 1. The second element 2 into 0 plus 1 into 1. The third element 0 into 1 plus 1 into 1, and the fourth element 0 into 0 plus 1 into 1. So the final result is 3 1 1 1. Okay. On the other hand, BA. So you are trying to find whether they are equal or not. So similarly we get 3 1 1 1. Okay. Therefore they are commutative. They are commutative. So these are the. So the question is, an electron moves around the nucleus in a circular orbit according to the Bohr model. The vector r and the instantaneous linear momentum vector p are shown in the diagram below. Okay, this question came in IIT-JAM 2009. So you have to find out the direction of angular momentum vector. So you know this because you have to undergo cross product, and cross product is always orthogonal to both the vectors, to the plane of these two vectors, isn't it? So it would be perpendicular to both r and p. Okay, and here the answer, we know that angular momentum is position into momentum. Then A cross B are orthogonal because with A and B, isn't it? And here A and B are also orthogonal with each other. Therefore the correct option is D. Okay, here look, this vector is A, this vector is B, and the A cross B is orthogonal to each other. They should be above the plane, isn't it? So all these three vectors, that means A vector, B vector and their cross product vector, are orthogonal to each other. So option D is the correct answer. Now move on to question number 6. This is regarding a matrix. So x and y transformed coordinates obtained from P and Q as follows. So you know this, just I have given you idea about this. So the correct set of linear equations represent x and y are, isn't it? So this is the matrix representation of two set of linear equations, a pair of linear equations. So what should we answer? The correct option is B here, because here A into P, okay, A1 into P plus A3 into Q, this should be the first element. Okay, this should form the first element, and the second element would be A2 into P plus A4 into Q, isn't it? So this is represented here, and this is a 2 into 1 vector, 1 matrix. I'm sorry, every time vector comes, but it is matrix, 2 into 1 matrix. So it would be actually 2 into 1 matrix again. Okay, so 2 rows and 1 column, the product. So x and y would be represented by these two equations. Okay. Question number 7. If a particle has linear momentum p equals to minus twice I plus j plus k, and at position r 3i minus j plus k, then its angular momentum is what? It came in 2010. Okay, angular momentum is position plus momentum. Therefore position, that means cross product of position and momentum. So it is I twice I plus j plus k, this is the momentum, and here r thrice I minus j plus k, so the cross product of these two. Okay, and the vector representing the linear angular momentum is this one. Okay, and the final result is minus twice I minus 5j plus k, and the correct option is here, option B. So option B is the correct answer. Okay, the question number 8. Two matrices are given as x equals to this one, y equals to this one. If xt is the transpose of x, then what should be the value of xty? So the given is x equals to this one and y equals to this one. Therefore, transpose of x is what? 1 5 now column, and 3 7 is another column. So first column is 1 5, 3 7 is another column, and their product x2 and then y, xt and then y. So xt and then y is what? The product of these two. That's when this one product this one times this one. Okay, so the result is 14 6 38 30, and here 14 6 38 30. So option C is the correct option. Okay, now move on to question number 9. Matrix which transforms x and y to minus x into minus y. So this is this question came into IIT-JAM 2012. So we have to try all the 4 options here, A, B, C, D. We have to take the multiplications or the transformations. Here the first one gives the result, that means this one with this one, x, y, okay, is actually only having only one element, minus x plus y. Okay, but B, this one with this one is not conformable. Okay, because number of rows and columns are not equal. And here number C, if you try this one, you will get the result minus x minus y. Here with D, we get the result minus y minus x. So correct option is actually D. Okay, next, question number 10. Which one of the following is an identity matrix? IIT-JAM 2015, this question came. So this is very simple, very easy to answer. This is the correct option, because here all the diagonal elements are equal. Not only that, they are unity. So this is the identity matrix. So the correct option is option B. Now move on to the next topic, which is determinant. So the determinant is a scalar value that is a function of the entries of a square matrix. It allows characterizing some properties of the matrix and the linear map represented by the matrix. Let's see. So suppose the order is same like matrix. Okay, the number of row into number of column. So if it is a third order determinant, and definitely it is a square matrix, number of rows must be equal to number of columns here. Okay, and for a third order there must be 3 into 3. So we are taking this as an example, and delta, this is the representation of a determinant, and here just 2 modular signs. Within this modular signs, the elements should be here. So it will look like this, and the value of this determinant is this element, the first element of the first row, into the multiplication of these two minus the multiplication of these two. Okay, so B2C3 minus C2B3. Next, plus this element into C2A3 minus A2C3, and finally this element C1 into A2B3 minus B2A3. Okay, so this is the result of the determinant. Now properties of a determinant. So this is the determinant. Firstly, theorem 1. The value of a determinant remains unaltered when its rows are changed into, or columns into, rows. Okay, so if you change the row into column or the columns into rows, then it will remain unchanged. Suppose this is the determinant. So if you can write this like A1, A2, A3 in the column, first row, and in the second row you can write B1, B2, B3, and finally in the third row, instead of A3, B3, C3, you can write C1, C2, C3, then the result would be the same. So this is theorem number 1. Theorem number 2, if 2 rows or columns of a determinant are interchanged, then the sign of the determinant is changed, but its absolute value remains unaltered. That means if A1, A2, A3 is shifted to the second column, on the other hand B1, B2, B3 is shifted to the first column, then this delta would become minus delta. Okay, so the absolute value is same, but their signs would be opposite to each other or one another. Theorem number 3, if 2 rows or 2 columns of a determinant are identical, okay, then the value of the determinant is 0. Suppose this is A1, A2, A3, and this is B1, B2, B3. If A1 equals to B1, A2 equals to B2, and A3 equals to B3, then this can be written as A1, A2, A3, then in the second column also A1, A2, A3 instead of B1, B2, B3, because A1 equals to A2, A1 equals to B1, A2 equals to B2, and A3 equals to B3. And this one is different, but these 2 columns are same. Or if these 2 rows have the same value, if A1 equals to A2, B1 equals to B2, and C1 equals to C2, in that case also the value would be 0. Okay. And finally, the fourth theorem, if every element of a row or a column be multiplied by a constant, then the determinant is then multiplied by the same constant. So if suppose this is k into delta, k is the constant, then you can write ka1, ka2, ka3, then b1, b2, b3, c1, c2, c3. Or you can also write this as ka1, kb1, kc1, then a2, b2, c2 as usual, a3, b3, c3 as usual. So if some common thing is taken out from any row or column, then you can take it out from the determinant and multiply with the whole result, absolute result of the determinant value. So this is theorem number 4. So these are about the properties of a determinants. So next, move on to the next question, which came in IIT-JAM 2017. The value of the given determinant is what? This is the determinant. So what should be the value? So just put the formula. Okay. So the first element of the first row into this 2 minus this 2. So this way we get the value minus 12. So the correct option is option A. Now move on to the next question, question number 12. The correct statement regarding the determinants of matrices R, S and T is, these are the determinants or the matrices and the corresponding values which are determinants. So determinant of matrix R equals to determinant of matrix S not equal to determinant of matrix T. So these types of options are given. Okay. So which one is correct? Okay. So let's think about this. Suppose here in the first row 3, 2, 4, or in the first column 3, 4, 1, in the second column 2, 5, 3. Here 2, 5, 3 and 3, 4, 1 have been interchanged. Okay. So these two are actually opposite to each other, isn't it? And here in this determinant you find that 3, 2, 4 has been transposed. That means it was the row, here it is the column, forming the column. Then 4, 5, 7 becoming the column again, and 1, 3, 8 become the column. So these two are equal, R and T are equal. Okay, but S is different. So which one should be the correct option? These two, option B. R and T are equal, whereas S is unequal. Actually it has the negative value. Okay, so the correct option is option B. Okay, so that's all about all these mathematical concepts, basic concepts of mathematics on matrix, determinant, vectors, etc. So thank you and have a nice day. We are going to start atomic structure and molecular structure in the next tutorial.